guys, welcome back. So what we're looking at today is lesson 12, using graphs to compare relationships. So let's go ahead and jump right into race to the bumper cars. So Diego, Lynn, and Mai went from the ticket booth to the bumper cars. Use each description to complete the table representing that person's journey. So Diego left the ticket booth at the same time as Tyler. Diego jogged ahead at a steady pace and then reached the bumper cars in 30 seconds. Lynn left the ticket booth at the same time as Tyler. She ran at a steady pace and arrived at the bumper cars in 20 seconds. Mai left the booth 10 seconds later than Tyler. Her steady jog enabled her to catch up with Tyler as he arrived at the bumper cars. So here we have their tables. So at time in seconds 0, Diego is 0 meters. He hasn't gone anywhere. Same for Lynn. Now Mai, she left 10 seconds later. So at a distance of 0, it was a time of 10. So hers is going to be a little different. So then for Diego, we see that at 30 seconds, he went 50 meters. So for 15 seconds, it'd be half of that. So it'd be 25. And so then to find out what our unit rate would be in 1 second, how far did he go? Well, taking our 25 and dividing it by 15, which gives us 5/3. So 5/3 is how far he goes. Now, for Lynn, we know that in 20 seconds she went 50 meters. So half of that, what would be half of that time? Well, that would be 10 seconds. So then for her unit, we do 25 divided by 10, which would give us 2.5. And 5/3 is the same thing as 1.6 repeating, just so you know. And then for Mai, at 40 seconds, she meters, so half of that would be 25. But if we take half of 40, that's 20. But we have the fact that there's this 10 seconds, this difference here. So it's actually 25. So 25 seconds, she went 25 meters. And so 40 or 50 divided by 40 would give us 5/4. But when we want to find 1 in this case, after 1 second, where was she? She was still 0 meters away because she hadn't left yet. So hers is a little different. Like I said, because she's got that delay on hers is not a proportional relationship. So it makes it a little more complicated. So we're going to take and graph each person's journey on here. So we're going to have Diego and Lynn are both at 0. So there's Diego, and then Diego at 15 seconds was at 25. Let me make this a little bigger so you can see it. So 0, 0, 15, 25, 30, and 50. So this is Diego's line. This is his representation of his speed and distance. My line's obviously kind of wobbly. All right, now Lynn, let's do a different color. Lynn, purple. So Lynn also at 0, 0, but at 10 seconds, she's up at 25. And at 20 seconds, she's up at 50. So there's Lynn. So Lynn is going faster than Diego. Okay. Now for Mai, there we go, screen froze. She started at 10 seconds. And then at 25 seconds, she was at 25. And at 40, she was up at the 50. So significant difference. It's wobbly. Sorry. So these are our three lines that we have here. The other one it mentions including Tyler's journey from the other day. Tyler had went 50 in 40 as well, but his started at the origin. So his would be here to here. Obviously, this line's going to be really, really wobbly. Wow, very wobbly. All right, so we kind of have our graph. Obviously, that should be a nice straight line, but doing it on here can't get quite as straight as I'd like. But there we have our graph. So which person is moving the most quickly? How is that reflected in the graph? So if we look at this, who has the steepest graph? Well, that would be the purple one. That'd be Lynn. So Lynn is moving the fastest. And we can see that both from the table and from the graph. But on the table, on the graph, it's hers is the steepest slope. And if we look back at the table, we can see their speeds. So Mai was going 5/4. Lynn was going 2.5 meters per second. Diego was going 1 2/3 meters per second. So we can see those at the unit rate. Now we can't see Mai's there, but taking the 50 and dividing by 40 shows us what hers would be. Okay, so looking at these, we can take and compare different linear equations to see what is going fastest and who has the greater rate. So compare is your keyword for this lesson. All right, space rocks and the price of rope. Meteoroid Perseid 245 and asteroid X travel through the solar system. The graph shows the distance each traveled after a given point in time. Is asteroid X traveling faster or slower than the Perseid 245? Explain how you know. So if we look, which one is traveling faster? Well, that's going to be the asteroid is traveling faster. Asteroid X. And how can we tell that? Well, steeper slope. So if we look at these, this one is going up and getting larger faster than what the Perseid 245 is. All right, and the next one, the graph shows the price P of different lengths L of two types of rope. If you buy $1 of each kind of rope, which one will be longer? Explain how you know. So if we look in terms of price and nylon, we've got the price, we've got the length, we've got cotton, we've got nylon. For $1, so our price, so let's say this is $1, our cotton value is actually going to be smaller than what it would be for the nylon, because we have to think about this. If this right here, let's say this is $1 on this price scale, $1 would be here. Make this bigger. Would be right here on the cotton, but it's going to be all the way over here for the nylon, which means it has a larger length than what the cotton does. So nylon would be longer because of that. So sometimes we have to be careful. It's not always just about the steepest slope. Sometimes we're looking at, for a certain value, how would we compare between the two for that same value? So be very careful in your comparisons. All right, if you guys have any questions, feel free to ask. Have a great day. Bye, guys.